Sometimes landmarks become an indelible part of the landscape, but their existence is just taken as a given that they'll always be there. And in our case today, this is in the form of a bridge, which until its demise had been in place for over 100 years. But although standing for a century, the Hintze Ribeiro Bridge on the evening of the 4th of March 2001 would suddenly collapse into the Douro River, taking 59 lives with it. Our story today would have its cause linked to a mixture of things, from illegal activity to the weather. Keep watching on the video to find out. Today we're looking at the Hintze Ribeiro Bridge disaster, aka one of Portugal's worst traffic accidents. My name is John and welcome to Plainly Difficult. This video wouldn't have been possible if it wasn't for my YouTube, Patreon and Ko-fi members. If you want to support the channel financially, then you can from just £1 per month. As always, the links will be in the pinned comment below. A bridge over a river in Portugal. This is the town of Castelo de Paiva, Portugal. It is near the Douro River, the largest river on the Iberian Peninsula. In the late 1880s, a plan was set to link the town to the nearby village of Entre os Rios to enable quicker transport times between the two population centres. Being a late 19th century project, the bridge would follow many of the design cues of other crossings across Europe, chunky iron and steel trusses placed on masonry piers. Construction work on the site began in 1884 and welcomed its first crossing in 1886, allowing for shorter journey times from both foot and equestrian-based traffic. The site was on the curve of the Douro River, next to the mouth of the Tamega River. This area would require parts of the bridge to be placed on top of sandy sediment-like ground. And remember this fact, very importantly for later on. Its design was as follows. It had 6 pillars made up of stone sat atop concrete pile caps and timber caps. The steel and iron truss deck sat on top of the columns on a bearing surface. Usually, well at least when built, only 2 of the pillars were consistently exposed to the flow of waters. These were numbers 2 and 3. They were protected from the power of the river by rock fill placed around the pile caps. The bridge had a length of 300 metres with 2 25-metre end spans and 5 continuous inner spans. Now, pillars 4 and 5 were built on top of the sandy deposits that flanked the river, on a bend, and had no type of protection whatsoever, unlike the rock fill of 2 and 3. The roadway deck is made up of 2 beams, 4.7 metres high, and was made up of an upper and lower flange connected by multiple truss bars inclined at 45 degrees. The road surface was a concrete slab supported by the side beams. The metal beams are then supported by the pillars. After the bridge's opening, over the decades it would be partially destroyed due to the 1919 revolt, requiring repair works a decade later to restore its structural stability. To accommodate heavier and heavier vehicles trundling across the structure, repair works to its roadway would be required. This involved widening the concrete roadway in 1959. Over its greater than 100-year life, the river bottom would gradually lower and widen, exposing more and more of the structure to the flow of water, and vitally exposing the unprotected piers to the river. During the 1970s and 1980s, 2 dams were built near the bridge, one upstream and one downstream. This would change the characteristics of the river by retaining solid flow, slowing down the build-up of sediment around the bridge. By the late 1990s, it was looking its age, and a few rather public concerns were made by both locals and officials as to the future of the structure, hoping to push a newer, more modern crossing. In 1999, president of the municipality of Entre os Rios was quoted in an article by Gustavo Sampaio. "We hope that tragedy will not be necessary for a new bridge to be built, but those words would turn out to be a premonition." The disaster. The start of 2001 along the Douro River was a very floody period. Between December 2000 and March 2001, there had been 5 floods in the region of the Hintze Ribeiro Bridge. The 5th of the major floods was well underway on the evening of the 4th of March 2001. Traffic, for the most part, had remained pretty standard throughout the day. However, the intense flooding had further eroded the riverbed around the foundation piles of the bridge, and today would be the day it couldn't take any more. At around 21:10 in the evening, a bus from the transportation company Asoduro is approaching the bridge. It has 53 people aboard it. But at 21:14, it is on the bridge along with 3 other cars. In total, at this moment in time, there are 59 people travelling across the crossing. At 21:15, the 4th pillar suddenly and without any warning gave way, crashing into the river below, sending down the 2 spans of bridge it was supporting. The 4 vehicles were plunged into the fast flow of the floodwater. The fast current dragged the victims up to 30 kilometres downstream. Some of the victims' bodies reached the currents of the Atlantic Ocean, depositing their remains as far as the north coast of Spain and France. Ultimately, no one who plunged from the bridge survived, despite the best efforts of local first responders and search and rescue efforts. Portuguese Navy divers and helicopters would spend weeks retrieving bodies, but sadly, due to the water flow, some would never be recovered. News of the collapse quickly spread across the country, and by the next morning, Minister of Transport Georg Kjellhol resigned from their position. A 70-kilometre detour would be set up for road users in lieu of the crossing, and multiple other structures across the country would be closed down for service, awaiting emergency repairs. The bridge would eventually be replaced, with the removal of the wrecked crossing beginning in June 2001. The bridge's replacement, carrying the same name, was opened in May 2002, sited 7 metres upstream. Another crossing was also built in the same area, increasing capacity later on. But although looking old, the bridge's disaster needed an explanation, which leads us on to the cause. In the aftermath of the collapse, investigators pored over the wreckage and looked at the water flows leading up to the collapse. Flows measured at the Carapatello and Torreo dams between 6 p.m. and 2 p.m. had doubled on the day of the disaster. The beginning of the 2001 failure goes way beyond the floods of late 2000 and early 2001, however. Although the immediate cause was due to the extra pressure of the floodwater undermining Pillar 4, the bridge shouldn't have been vulnerable. It had stood there for over a century. Investigators would have to look way back into the area's history, some 25 years before the collapse. You see, the sandy deposits along the Douro River proved to be very useful for building. Illegal extraction of sand had begun in 1975, directly next to the bridge for the construction of a nearby reservoir. This harvesting of sand wasn't legally allowed, but was unofficially ignored. The extraction reduced the sandbar around the bridge, turning the river from this photograph to this. After the reservoir was completed, dredging of the river continued for harvesting of sand a few kilometres upstream. This would have a catastrophic impact. This resulted in less sand making its way downstream, which in turn meant the depleted sandbar around the bridge couldn't be reformed. The depressions in the riverbed created by the dredging upstream caused sand to become trapped and not flow downstream. Thus, the riverbed increased as the flow of water naturally carried away deposits with this. It was basically exposing more and more of Pillar 4's foundations to the flows of the river. Between the 1920s and 2001, the riverbed had deepened for the best part of 20 metres. During surveys in 1988, it was estimated that there was around 9 metres of sand above the foundation of Pillar 4, but by 1998, it was thought to be as low as 1 metre. Basically, over the years, the foundations, particularly around Pillar 4, was being dug out around it, causing a scour. Eventually, there wouldn't be enough riverbed to hold the pillar down, and at that point, disaster was assured. Data about the increase in riverbed depth had been collected over the years, with multiple surveys being undertaken of both the river and the bridge, and this was known by officials and locals at the time. Thus the complaints at the end of the 20th century, where concerns were sparked over severely corroded iron sections and the general state of repair of the bridge. Now, some people would be charged for the disaster. 4 engineers from Junta Autónoma de Estrada, JAE, and 2 engineers from a survey company would be criminally indicted for professional negligence. However, in 2006, all 6 were acquitted. So that's my video on the Hintze Ribeiro Bridge disaster. It's going to be a 4 on my scale, and this is what I've got for my root cause analysis card. Do you agree? Let me know in the comments below. This is a Plain Difficult production. All videos on the channel are Creative Commons Attribution Share Alike licensed. Plain Difficult videos produced by me, John, in a currently not so bad corner of southern London, UK. And all that's left to say is thank you very much for watching, and Mr. Music, can you play us out please?